This example is from section 9.1 in MGF 1106, and in this problem we have two angles. We have angle 1 over here to the right, so angle 1 is the union of these two rays, and the measure of angle 1 is denoted with this x right here. So the amount of rotation from the initial side to the terminal side is x, and that will be in degrees. Now the measure of angle 2 is over here on the left. It's formed by the union of those two rays. So the amount of rotation between those two sides is called the measure of angle 2, which has the measure of 20x plus 33. But we do not know what x is. But we do know that these two angles are supplements, which means they form a straight angle or a straight line, which measures 180 degrees. So the measure of angle 1 is x, over here to the right. And if we add the measure of angle 2, which is 20x plus 33, those two measures should add up to be 180 degrees. Now when we're adding like terms, x plus 20x would be 21x plus 33, which is not like to it because it doesn't have an x after it. It's just a constant. And then to solve for x, we would subtract 33 from both sides. So we'd have 21x is equal to 147. And if we would like to know what x is, we'd have to divide by the coefficient of 21 on both sides. And x is equal to 147 divided by 21, which works out to be 7. Now that's the value of x. And if you recall back at the beginning, x is just the measure of angle 1. So the measure of angle 1 is equal to 7 degrees. Now x is 7, so if we go to measure of angle 2, the measure of angle 2 is 20x plus 33. So that would be 20 times x, but now we know x is 7 plus 33. So we have 140 plus 33, which is 173. So the measure of angle 2 is 173 degrees. And again, how we got that was we went 20 times 7 to get 140, and then we added 33 more to get 173. Now, one thing you should notice, those two measures, 7 degrees and 173 degrees, do add up to be 180 degrees, which means they are supplements of one another. And if they are put adjacent to one another, they will form a straight angle.